Welcome my dear learners for this course on engineering graphics. In this module 4 we were discussing on development of lateral surfaces of solids. We are heading for the final problem of our discussion on module 4, that is problem number 15 of our discussion. States that a funnel is made of sheet metal. The funnel tapers from 60 mm to 30 mm diameters to a height of 25 mm and then forms to a cylinder with a height of 50 mm. Bottom of funnel is beveled off completely at an angle of 45 degree to axis. Draw the development of funnel. The final problem of our discussion on development of lateral surfaces of solids is based on funnel. So people might have already know what is the meaning of funnel. The given problem is like this. We have a funnel. At the top we have a tapering section from diameter 60 to diameter 30. Diameter 30 for a height of 25. This height is specified as 25, correct? And then forms to a cylinder, and he also states that at the bottom the funnel is beveled off completely at an angle of 45 degree. Means what? At the bottom we are cutting from one of the corner, the cylinder is beveled off at an angle of 45 degrees. So therefore cut it at an angle of 45 degrees, which means to say that we are getting a truncated cylinder at the bottom. So this is first part of the funnel, this is second part of the funnel, and the height of the cylinder is 50 mm. So this height is given as 50. So this is a required funnel which we want to develop now. Now in order to develop this, if I look at it from top, I can observe two circles. One is of 60, another one is of 30. That's all. Front view will be like this. We have a tapered conical section, that is frustum of cone of diameter 60 and 30, height is 25, and we have truncated cylinder. We have already learned how to do the development of cylinder and how to do the development of cone. Recollecting those two, let us complete the sheet metal drawing of funnel. Now let me draw first let me lay down top and front view of the given problem. If I lay down top and front view of the given problem, we have funnel. Let me take this as a reference line and call it as x and y. Call this as x and y. And first, as I said, whenever a solid is resting on HP, we should always start from the top view. Let us call this as vertical plane. This is horizontal plane. In the top view, I can see only two circles of diameter 60 and 30 respectively. So therefore, draw two circles. Let me take a reference. So from the center, let us draw two circles. Let us draw two circles of diameter 60. So radius is 30. I taken radius as 30. Draw the top face circle of the cone. So drawn radius 30, diameter 60. We have one more bottom face to 30. So draw one more circle of radius 30. Taken radius 30, draw one more circle. Radius is 15, diameter is 30. Radius is 15, diameter is 30. I taken 15 mm as radius. So I got 30 mm diameter circle. So the bottom face is how much? Diameter of 30. This is of diameter 30 and the top face is of diameter 60. The top face is of diameter 60. Right? Let us mark that. So the bottom face is of diameter 30 and the top face is of diameter 60. So this completes the top view of the funnel. Now draw the front view. So to draw the front view, let me take the projection. First we have a cylinder at the bottom, which is beveled off at an angle of 45 degrees. Correct? First we have a cylinder. The height of the cylinder is 50. So draw the axis, and the height of the cylinder is 50. The height of the cylinder is 50. Since it is beveled off, let me stop at this point and draw a very thin line here. So this is what we have. From there, for 25 we have a taper. So measure 25 and lay down the axis like this. Draw the axis. There we have the top face of this cone, that is diameter is 60. From there you have the taper. From there we have the taper. Right? Let me connect these two. Clear? So this is the given problem. We have a beveled truncated section of the cylinder at an angle of 45 degrees. So measure 45 degrees measured from the corner. Now you bevel it off from where I measured. Yes, correct. You bevel it off at an angle of 45 degrees. Beveled at an angle of 45 degrees, you will get funnel like this. So this is the required funnel. This angle is 45 degrees. This angle is 45 degrees and this height is 50. This height is given as 50. This height is specified as 50 for us, given in the question, and this height is 25. This height is how much? 25. So this completes the front and top view of the given funnel. Since we have cone and cylinder, let me mark this as part A and this as part B. So I want to separately develop part A and part B, then I can attach at this point using soldering on a sheet metal. So now let me do development of A and B separately. Now what is B and what is A? A is frustum of a cone of diameter 60 and 30 for a height of 25, whereas B is a truncated cylinder of diameter 30 and height 50. Correct? 60 to 30, height is 25 is a cone and cylinder height is 50. So first let us draw the development of cylinder part B. So if I move for development of part B, the front view of which is the front view of this is a rectangle of dimension 50 cross 30. So let me draw that first. 50 cross 30. We have 50 cross 30. 50 cross 30. You draw 50 cross 30 and fix a new xy line for which x and y take it as VP and HP. From here I want a bevel of 45 degrees. 45 degrees, you bevel it off. So bevel it off at an angle of 45 degrees. Draw, lay down the bevel. So this portion is retained and this portion will be removed. So for the portion which we are removing, let me mark it with a very light line, very thin line like this. So this top portion will be retained, and also I want the axis. Let me mark the axis. So axis will be here. So the top view of this cylinder will be a circle of radius 15 millimeters. Top view of this cylinder is a circle of radius 15 millimeters. So therefore let us draw a circle for this projection. Let us draw a circle for this projection. So we have the projection like this. We have the projection like this. Draw the circle for radius of 15. So draw the circle for radius of 15. So draw on the top view. Now we know that in order to develop cylinder, we want 8 divisions. So therefore divide this into 8 equal halves. Divide this into 8 equal halves, that is, draw sections at angle of 45 degrees. So measure 45. Here also you measure 45. So divide it into 8 parts. Divide this into 8 parts and give marking as A, B, C, D, E, F, G and H. Now take the projection. So if I take the projection from here and also from here, here we will have, let us take the markings as A is visible, A1 is invisible. Let me take it as A1, B1, C1, D1, E1, F1, G1, H1 and A, B, C, D, D1, E, E1, F, F1, G, G1 and H, H1 like this. Now if I project further, I will get projections like this. Now looking at the from here, A1 dash is visible. Here I will get A dash. Here I will get B1 dash, H1 dash. Here I will get B dash, H dash. At the center I will get C1 dash, G1 dash. You will get C dash, G dash. Here it is D and F. Here it is E, E1 dash, E dash. Here D dash, F dash. So since here it is become clumsy, I have not written here. If there is a space, you can write it here. That is D1 dash, F1 dash. Now from A to A1, A to A1 we have bevel here. Let us call it as 1. Next from B to B1 it is 2. Next C to C1 it is 3. D to D is 4 and then we have 5. Next F is 6. F is 6. G is 7. G is 7 and H is 8. H is 8. So totally we have 8 cutting points. Since for cylinder we can directly solve by using radial line method of development. So project it and draw the radial line. So which can be solved directly by using radial line method of development. Let us use radial line method of development to complete the development of this cylinder, for which the height is known. Now when I cut from one of the point for this vertical cylinder and open it, the length will be circumference, correct? So circumference length is pi d. So pi times the diameter. The diameter of this is 30. So this diameter is 30. This diameter is given as 30. So circumference will be pi times 30. Pi into 30 will be 94.25. 94.25. So from here, let me measure 94.25. 94.25. 94.25. So I got 94.25 at this point. So I can erase this. This is not required. Can erase this also, which is not required. So we have measured from here. Mark it. Now we have divided this into 8 equal halves. So now I should divide this pi d into 8 equal halves. That is the question to be answered now. How can we divide this into 8 equal halves? Yes, you know how to divide this into 8 equal halves. This is pi times the diameter, that is pi into 30, which is 94.25 mm. Now to divide this into 8 equal halves, arbitrarily you cut arcs, 8 arcs. First you draw a line for arbitrary angle. Let me draw a line for arbitrary angle and divide it into 8 halves, 8 equal halves of unknown dimension. So this line length is also arbitrary, the angle is also arbitrary. Now take arbitrary measurement arc. From the beginning point, you cut arcs at equal intervals. I want 8 divisions. This arc dimension is also unknown. So unknown angle, unknown length, unknown dimension arc. You cut 8 equal arcs on this line. 1, 2, 3, 4, 5, 6, 7 and 8. Done. Now connect the last one to last one. Now you draw parallels, you will get 8 equal divisions. Now you draw parallels like this. Keep drawing parallels, you will get 8 equal divisions. Yes, we have divided 94.25 into 8 equal halves. Now we can call this as A1 A. So there is nothing like these longer edges in case of a cylinder. So therefore draw very smooth vertical lines like this. Draw very smooth vertical lines like this. Draw very smooth, very thin vertical lines like this. This will be B1B, C, D, E, F, G, H, closing side is A. This is C1, D1, E1, F1, G1, H1, closing side is A1. So now just you transfer these points. So for A1 to A, we have point 1 here. This should be at the last also. So take it to the last vertical line A. So thereby we have transferred point 1. Next we have 2 and 8 for B and H. We have 2 and 8 for B and H. So this is for B and H. B and H. So this is 2 and this is 8. Next we have 3 and 7 for C and G. Transfer it. 3 and 7 for C and G. C and G. This is 3 and this is 7. Next we have 4 and 6 for D and F. 4 and 6 for D and F. 4 and 6 for D and F. So this is 4, this is 6. Correct? So now you draw smooth curve. Draw smooth curve with dark line. Dark, free and smooth curve like this. So this is 5. So this is the required development. Bottom portion, here we retain the top portion and bottom portion will be removed. So therefore dark the top portion. Dark the top portion. Dark the top portion. So this top portion will be retained and the bottom portion will be removed. So this is the required development of part A. Part B. This is the development of part B. Clear? So this is removed. So this is not required. Draw very thin line. So this is also removed. Draw very thin line like this. Draw very thin line like this. So this completes the development of part B. Now I want development of A. For development of A, which is a cone, we know how to draw development of cone, which we have discussed in both problem number 13 as well as 14. Wherein which in problem number 13 I have clearly discussed how to draw frustum of a cone, recalling which let us finish part A. For which I want slant generator height. How much the slant generator height is required for calculating the angle of swing. Now let me reconstruct this one again and find out how much is the slant generator height. So for part B, let me solve here. Let me solve here for part B. Find out how much is the slant generator height. Height of the slant generator and calculate angle theta to solve development of part A. So that is for cone top face. This face is diameter of 60. So draw the diameter of 60. So draw diameter of 60. Draw the diameter of 60. Drawn. Mark the center. Fix the axis. So don't worry about top view. Top view is not required. We want only front view. So therefore I am laying down the front view. Now this is 25. Measure 25. Measure 25. Here we have diameter of 30. So therefore mark 15, 15 on either side. Mark 15, 15 on either side. So connect these two. Connect these two. Connected. So this is diameter of 60. This is diameter of 30. And this height is 25. This height is 25. Clear? Now extend this further to intersect the axis and find out how much is the length of slant generator. Extend this and find out how much is the length of slant generator. So I want all these dimensions. How much is this one? Let me mark this 25 that side. So how much is this one? And how much here? All these dimensions are necessary. So if I measure this one, I am getting this as 30, and I am getting this as 58. I am getting this as 58 mm, which was required for the development, right? Now calculate angle theta. So for cone, we know that angle theta is given by slant generator height by base radius is how much? Base radius divided by slant generator height into 360 degree, correct? So theta is equal to, how much is the radius of the base radius? Is 30. 30 is the base radius. Slant generator height is 58 into 360 degree. So therefore theta will be, base height of this cone is 60. So therefore radius will be 30. Slant generator height is 58 into 360 degree, which is equal to 186.2, which is equal to 186. Let me take it as angle as 186 degrees. We know the arc radius is 58. So measure this 58 measured. Let me draw for 1:1 scale. Since space is a constraint, let me mark for 58. Take the radius as 58. Now measure the angle. Measure the angle. So if I measure the angle, so from here to here it is 180. 180 plus 6. 180 plus 6. 186 degrees is what I should take. Take it as 186 degrees taken. So overall angle from here to here is 186 degrees. Clear? Now we want arc at 30. So measure 30. Measure 30 and draw an arc. One more arc. Like this. So this is the required development of cone, right? So from here till here it is 30, and from here till here the radius is 58 mm. So this is the required development of cone. So this is retained and this portion will be removed. So this is what required. This is not required. Mark it with a very thin line. So dark this outer boundary also, like this. So this is development of A. So this is development of B and this is development of A. Putting together I will get the sketch. So this I drawn for scale 1:1 because of space constraint. This is for scale 2:1. Rest all is for scale 2:1. Only this diagram I drawn it for 1:1. But follow the dimensions what I have indicated to 1:1 scale. You will get the problem accurately. So this is how we should solve for any given question on funnel. We can also have funnel without bevel, that will become truncated cylinder. No need to worry, no cuttings will come, just you draw a rectangle of dimension height cross circumference 2 pi r or pi d. This height is missing, right? So this height is 50 given, and this angle is also given. This beveling angle is 45 degrees. This beveling angle is 45 degrees. So this is the complete solution for problem number 15, and this completes our discussion on development of lateral surfaces of solids. From next lecture I will begin module 5, that is isometric projection and orthographic projection. That's all from this lecture. Thank you all.